Hi, I'm Mr. McCollum, and this is the lecture covering what material that we talked about on February 11th, 2011. Alright, so we continued that activity where we talked about calculating pressure in mathematics, and we're going to continue that today, followed by a handout, and most of the periods left off on period problem 5. So let's take a look and continue on from there. Alright, this is the problem. It says, suppose you go on an airplane for a trip far away from the cold Ohio weather. The plane reaches an altitude of 13,000 feet, or roughly 3,963 meters. What percent change in pressure is this compared to sea level? So let's say I supply the cabin pressure, which is 8,585 pascals, or 8,585. So let's start with the information we're given. Alright, we know cabin pressure, which is 8,585 pascals. We know altitude, which equals 13,000 feet. We're just going to write down meters since we use the SI system here in science. And finally, now, we also know one other piece of information. If we look at the example from the other day, problem 4, it gives us a value of for sea level, okay? So sea level pressure equals 101,000 pascals. So, what is the problem actually asking us? Well, let's read it. It wants to know what percent change in pressure is this compared to sea level. So, many of you might be familiar with how to calculate changes in pressure by using the simple proportion system that looks something like this. Percent over 100 equals is over of. Now the problem clearly asks us what percent, right? So the percent is the unknown, so that becomes x. Alright, but what is and what is of? Well, it turns out we need to do two calculations in order to get to the final answer. Alright, now notice it mentions change in pressure. Where is pressure changing? Well, it's changing from sea level to cabin pressure. Now keep in mind these numbers aren't realistic, but they are used to help you do a calculation. Alright, so pressure is changing from sea level to cabin pressure. In order to get the difference, we subtract. The number you get turns out to be something that roughly looks like 92,415 pascals. Okay? So that's your difference. So what part is your is and what part is your of? Well, let me help you. If I were to rewrite this problem somehow, okay, where I said that what percent of 101,000 is 92,415. So is up here and of is down here. So continuing over here, we cross multiply. Okay. Do that operation on the right. 92,415 times 100 makes 2 more zeros. And then you want to do the opposite of the left operation to both sides, which is division. Divide both sides by 101,000. And your final result should be about 91.5%. All right, number 6. This one looks a little easier. It says, suppose you go shopping in a mall with many, many floors of stores. You ride in an elevator to get to each floor. With each floor you go higher up, the air pressure increases at a rate of 10 pascals. And the question asks, what is the new pressure at floor 1, 2, 3, 4, 15, and then 287? I gave you the first and second floor, 10 and 20. So if I were to say in the first two examples, I multiplied by 10 and got 10, multiplied by 10 and got 20. At floor 3, if I did the same thing, I would get 30. At floor 4, I would get 40. At floor 15, I would get 150. And at floor 287, I would get 2,870. That one's pretty easy for most of us to see. Problem 7. A woman in an elevator next to you goes from floor 172 to floor 86. What is the difference in pressure between the floors? So start off with the picture here. Here's a woman in an elevator, and she is here at floor 172, and she is going down to floor 86. How many floors did she change? 172 minus 86. 86. Alright, so now that we know the number of floors, what's the difference in pressure? Well, we have 86 floors. Times 10 pascals of pressure change per floor. Floor cancels. And 86 times 10 is 860, last remaining unit, pascals. Right. Example 8 says, imagine that floor 182 reaches an elevation of 910 meters. If the surface area of the elevator is 4 square meters, what is the total force on the elevator? Now, in this problem, I give you a new equation to use, right? I give you a new equation, force equals pressure times area, and the SI units represented by each. So, how do we find this? Well, how about that problem for number 6 where you multiplied by 10? Okay. Well, you're at floor 182, and if there was 10 pascals of pressure change per floor, multiply by 10, and you get 1,820 pascals, right? Because of the rule of tens. Just add a 0. Now we have the components necessary to do the calculation. So I gave you the equation that force equals pressure times area. Alright, now that we know pressure, let's plug it in. F equals 1820 pascals times the area, which is represented by 4 square meters. Do that calculation, and you get 7,280 pascals times meters squared, which equals the same thing as 7,280 newtons. Alright, so on the worksheet that you have received, the problems go in the same order as the example problems. So the scenario is changed a little bit and the numbers are changed, but if you use the same equations and the same numbers in the same sequence, I should say, if you use the same method, the numbers are obviously different, but as long as you use the same process and the similar equations about the operations will come out to be fairly similar in behavior to the answers you got for the examples. So try to do those and see me with any questions that you may have.